So we've got example 2, right? Example 2 states 3x plus 2y is equal to 13, and we have 3x is equal to 2 minus y. So when we are dealing with simultaneous equations, what I like to do is I like to choose one of the equations, make one of the variables my subject, and substitute that into the second equation. So what I'm going to do is I'm going to start with 3x equals 2 minus y. The reason I'm starting with this is, as you can see, the coefficient of y is -1. So it'll be easier to make y the subject of my formula. So we're going to start with 3x minus, or rather 3x is equal to 2 minus y. From here, I'm going to solve for y. So I'm going to move -y to the left and 3x to the right. That gives me y equals 2 minus 3x. So I now have an equation for y. From here, I'm going to call this my equation 1. I'm going to take this equation 1 and I'm going to substitute it into this. We'll call it equation 2. So here we have 3x plus 2y equals 13. 3x plus 2y equals 13. We'll call this equation 2. You don't even have to call it 1 and 2. It doesn't really matter, as long as you know that you need to substitute one into the other, okay? So yeah, all we are now going to do is substitute 2 minus 3x into y. And take note that whenever you substitute, you need to make use of brackets, okay? So from here, we have 3x plus 2. Now we need to substitute for y. So we know that y is 2 minus 3x, and that is equal to 13. So as you can see, the second equation was left as is. Nothing was changed except for y. All we did was substitute into that y position. So from here, we are going to simplify and solve for x. So we can bring down 3x. We can distribute positive 2 into the bracket, giving us 4 minus 6x equals 13. From here, we need to solve for x. So we can see that we have like terms. Our like terms are 3 and -6x. So all we are going to do is say 3 minus 6, that gives us -3x. We move forward to the other side, so we have 13 minus 4, and we know 13 minus 4 is just 9. From here, we now have x as equal to -3. So we found x. Now that we've found x, we need to go and find y. Keep in mind that we found x to be -3. Now that we have x as -3, we are going to choose one of the equations. We can take this equation, or this one, or this one, doesn't really matter. We just need to take one of the equations, substitute x, and solve for y. So I'm going to go with this equation here. We called it equation 1, right? So y equals 2 minus 3x. From here, all we are now going to do is substitute x, which is -3. We can put this into our calculator, and we know that -3 times -3 is +9. 2 plus 9 is 11. So we therefore have y as equal to 11. Now that we have both the x and y value, we can check if our answer is correct. How do we do that? So we go back to the original equation, we substitute into the equation and see if the left-hand side is equal to the right-hand side. So here, if we were to substitute, we calculated x as -3, calculated y as 11. So -3 times 3, that is -9. 2 times 11, that is +22. 22 minus 9, that is 13. So as you can see, both sides are equal. You can do the same thing with this equation. As long as the left-hand side is equal to the right-hand side, it means that your answers for x and y are correct. So let us move on to example 3. So for example 3, we have x into x minus 3 plus y into 3 minus x, and that is equal to 0. Take note that there's only one equation, okay? So what we are now going to do is we need to turn this one equation into two equations. How do we do that? We know from solving equations that anytime the product of two terms is equal to 0, we can separate it, because it means that one of those terms or both of those terms is equal to 0. So let's take an example from something that you are more used to seeing. Let's say we have 6x squared minus x is equal to 0. Let's actually get rid of the 6. So let's say we're dealing with this, right? From here, we can take out a common factor. We have x minus 1 is equal to 0. Do you see that the product of two terms, one term is x, one term is x minus y, is equal to 0? And we know that if one of the terms is 0, it means that the whole thing will be 0, right? Because anything times 0 is 0. So what we do from here is we separate it. X equals 0, or x minus 1 equals 0, and x is equal to 1. Do you see that we've now created two equations from the one equation? So if you want to turn one equation into two, try to make them a product of two terms that is equal to 0, okay? So that is what we are going to do for this example 3. So from here, we are going to distribute the x into the bracket, and that is going to give us x squared minus 3x. We're then going to distribute y into the bracket, and that gives us 3y minus xy, and that is equal to 0. Okay, this is one option. Then you can go on to use your grouping factorization and turn it into two brackets equals to 0. That's one method. A second method is to notice that the two brackets are kind of similar. We have x minus 3 in one bracket and 3 minus x in the other bracket. So you can see that x is positive in the first bracket, but negative in the second bracket. -3, or you could say 3, is negative in the first bracket, but positive in the second bracket. So who can tell me, how do we turn both brackets into x minus 3? How do we turn 3 minus x into x minus 3? What can we do? Who has an idea?
Um, okay, so like what we do is that we take out the negative, right? So the negative is basically like the common factor in a way. So then it becomes negative y instead. And then you take the x in front and then the 3 at the back, and then the signs reverse.
Thank you. That is correct. So all we are going to do, as your classmate has mentioned, is factor out a negative. So currently, let's leave that for now. Currently, we have 3 minus x, right? If we want to turn this into x minus 3, take out a common factor of negative. When you take out a common factor, this is what you need to do. Take the term 3, divided by the common factor, and you get -3. Whatever you get after you divide by the common factor, that is what's going to go inside of the bracket. So if you struggle with finding common, or if you struggle with identifying what's supposed to go inside of the bracket, after you take out a common factor, take the term, divide it by the common factor. The answer is what is supposed to go inside of the bracket. That is it. So here, 3 divided by -1, that gives you -3. Then -x, which is the second term, divided by the common factor, which is -1, and that gives you +x. So we now have -3 plus x. Keep in mind, 2 plus 3 is the same thing as 3 plus 2. Doesn't matter which you put first when you're adding. So we can move it around inside of the bracket and have x minus 3. It's the exact same thing. Okay. So from here, all we are going to do is take out a common factor of -1. So we have x into x minus 3 minus y into x minus 3 equals 0. Now, if you are confused on why we have -y, keep in mind it was originally +y into 3 minus x. If you take out a common factor, you bring down the y, you multiply it by the common factor, because the common factor goes in front of the bracket, right? And we know that +y times -1 is -y, and that is why we have -y into x minus 3. Now, let us continue. So, according to grouping factorization, or according to taking out a common factor, whichever method you want to use, this will then become x minus 3, x minus y equals 0. If you are using your grouping factorization, the trick is to write the common factor or the common bracket once. Take note that the common bracket is this x minus 3. Write it once. In the second bracket, you write the leftovers. The leftovers are x and -y. That is using grouping factorization. If you want to use taking out a common factor, all you would then do is, if you have x into x minus 3 minus y into x minus 3, and you want to take out the common factor. So take out x minus 3, and what are you left with inside of the bracket? Remember what we discussed earlier? If you want to take out a common factor, you take the term, divide it by the common factor. That is how you identify what is left behind. So x into x minus 3 divided by the common factor, that cancels that, you are left with x. Do the same thing with the second term. -y into x minus 3 divided by the common factor, which is x minus 3. That cancels that, and you are left with -y. That is how we ended up with x minus 3, x minus y. So irrespective of which method you use, you end up with the same thing. And grouping factorization is basically the same thing as taking out a common factor. So whichever is fine. Now, before I move on to separating the two brackets, does anyone have a question, or is anyone confused? And does anyone need us to repeat one of the steps? If you need us to repeat one of the steps, please unmute yourself and speak up, and I will attend to you.
Okay, sir.
Yeah.
Sir, I see that you're on example 3, and it seems like I missed example 1. What was that?
Oh, I didn't do example 1. So at the beginning of the class, I said that some of them are quite similar, and we only have an hour together, so we won't be able to do all 20 questions. So whichever questions were similar, I just took out the more interesting ones or the more difficult ones, as compared to, yeah. So if they were similar, I took out the one that looked slightly more challenging or whatever the case was. But yeah, we are only doing the ones where you see there's a like a red highlighted thingy on the number on the example. That's what we are doing. So there's 20 questions. Remember, I stated in the group that this PDF is going to get uploaded to that OneDrive folder. You can access this PDF on that OneDrive folder. Whoever sent me their email address, you should have received an email if we communicated. And yeah, this thing will get uploaded later today, and then you can attempt the questions that are not highlighted or whatever we did not finish from here. Okay,
Okay, thank you, sir.
you're welcome. So before we continue, is everyone okay? Does anyone have any questions regarding example 3? Okay, so let's continue. Now,
So
yes.
can I ask? So, sir, even like if you use the first method without using the groupings method, it was still gonna give us the same answer. Like
The
how do
first
you?
where I distributed X and Y into the bracket.
Yes, sir. So how do you do that? Like you just okay. So can you please like in a way demonstrate to us that how it will like how it will be when you use that one?
So that's just a longer method of this. If you distribute it, you still have to come back and factorize again. So that method was a bit of a longer one. It's kind of like if you take one step back, then take one step forward. You basically, the step was, you didn't really need to do that step. So if we did that, we'll do it. So we get x squared minus 3x plus 3y minus xy equals 0. From here, you would then need to take out a common factor again. So basically, we're going back to the original question. So yeah,
Oh, okay. So
there
I
was no
understand. Oh,
real.
I see now. Okay, I see
That
now. So thank
method,
you.
I just spoke about that because sometimes I noticed students don't like to take out a negative. So they prefer to expand and then factor out the negative for some reason. But remember, it's completely up to you. If you want to use this approach, it's completely fine. Do what works best for you at the end of the day. So yeah, if you use that first method I discussed about expanding, you would eventually come back to the exact same thing. So yeah. So let us continue. So now we have the product of two terms that is equal to 0. All we are going to do from this point is separate the equations. So we have x minus 3 is equal to 0, or x minus y is equal to 0. From here, we can solve for x. So we have x is equal to positive 3. Here we have x is equal to y. And we know that x is equal to 3, which then means that y is also equal to 3, because the equation on the right stated that x is equal to y. If x is 3, that means y is 3 because x is equal to y. And that is it. If you want to check if your answer is correct, substitute back into the original equation. So here x is 3, y is 3. If you put this into your calculator, you'll end up with 0. So we know our solution is correct. If you want to test whether or not what you did is correct, always substitute it back into the original equation. If x is equal to y, that means not if x is equal to y, please disregard that. If the left-hand side is equal to the right-hand side, then you know that you are correct. So to repeat once more, if you want to check if your solution is correct, take x, take y, substitute it back into the original equation. You can choose whichever. In this case, we had one equation. You saw that in example 2, we had two different equations. So Choose whichever equation you want. It doesn't matter. You can even use both. Substitute it back into the equation, and then, yeah, if left-hand side equals right-hand side, that means it's fine. Now, before we continue, does anyone have any questions? Okay.
Sir,
Yeah.
sorry. Sir, may you please explain the final answer? Like, why is it x equals to y equals to 3?
Okay, so here, if we look at this equation, right? This equation came from here. So here, if you move this negative y to the other side, you end up with x equals 0 plus y. We know that 0 plus y is y. Now here it states that x is equal to y, which means that whatever y is the same thing as x. Whatever x is the same thing as y. X is equal to y. And we just calculated in the previous equation that x is equal to 3. So if we were to substitute x as 3, we get y is equal to 3. I just decided to put it on the side because I don't want to have to rewrite y. Does it make sense?
Yes, it does. Thank you, sir.
Okay. So keep in mind, this is still from grade 10. We've not reached any grade 11 stuff as yet. So this is still from grade 10. So that's example 3. I think we can even skip example 4. I want us to move on to something that's a bit more challenging. Because if you notice, example 4 is basically the same thing as example 2 and example 1. That's what I meant by, if you go through past papers, right, you'll see a lot of the time the questions are very similar. So if you go back and take all the past paper questions and just try to solve them in your free time, you'll be fine. Just practice as many as you can. So let us jump all the way to, let's see, something that's highlighted. Let us jump to 11. For example, 11, we have our first equation that states m is equal to 2 to the power 0.2. Our second equation states that m to the power b is equal to 16. So if you notice, we have a value of m. We know that m is equal to this 2 to the power 0.2. If we take this and substitute it into the second equation, we can then solve for b. So all you're now going to do is play with your exponents. You are busy with exponents right now in math, so hopefully that shouldn't be too much of a task. So from here, we have the second equation, that is m to the power b is equal to 16. From here, we are going to take this value of m and substitute it. So we now have 0, or rather 2 to the power 0.2 raised to the power of b is equal to 16. Now there's an exponent law that you dealt with, whereby if you raise an exponent to another exponent, or if you raise a power to another power, what are you supposed to do? Who can tell me?
Multiply.
That is correct. So if you raise an exponent to another exponent, if you raise a power to another power, all you are going to do is multiply the exponents. So 0.2 times b, that gives us 2 to the power 0.2b, and that is equal to 16. Now, this is still exponents. We're still busy with exponents. What are we going to do to 16? Who has an idea?
Get a prime factor.
Perfect.
That is correct. Because we want to solve for b, which is an exponent, we need to get rid of the bases. In order to get rid of the bases, we need to make the bases the same. So we need to turn 16 into 2 to the power something. And we know that 16 is, I think, 2 to the power 4. Let me double check. Yeah, 16 is 2 to the power 4. So we are now going to turn that 16 into 2 to the power 4. So we have 2 to the power 0.2b is equal to 2 to the power 4. From here, because the bases are the same, we drop them, and we have 0.2b is equal to 4. And now it's just basic equation rules. We divide by the coefficient of the variable. So if you divide both sides by 0.2, you are then going to have b as equal to 20. And that is it. Our value of b is 20. Does anyone have a question? Something you do not understand, or something you would like us to repeat? Okay, then let us continue. So let's see, let's have a look at question number 13. So question 13 is a single equation. So it's quite similar to that example 3 that we did. So from here, we have 3 to the power y plus 1 all over 32 is equal to the square root of 96 to the power x. So we are dealing with exponents once again. So if we look at 3y plus 1, what can we break this up into? Who has an idea?
3x multiplied by 3 to the power of 1, or just 3?
That is correct. So 3 to the power y times 3 to the power 1. Remember the first exponent law that you dealt with? That stated that if you multiply like bases, you write the base once and you add the exponents. Basically, what you are doing now is you're doing that rule in reverse. So because you have one base and your exponents are being added, you can break it up by moving in reverse. If the rule is write the base once, add the exponents, to move in reverse is to write it twice and break up the exponents, okay? So we are going to convert 3 to the power y plus 1 into 3 to the power y times 3 to the power 1. Now, let's have a look at the right-hand side. What can we convert the square root of 96 to the power x into? Who has an idea? Think of a square root. What can a square root be converted to in an exponent form?
So you can write 96 in brackets, and then outside you write 1 over 2, if that's correct.
That is correct. So a square root in an exponent form is 1 over 2. A cube root in an exponent form is 1 over 3. You can turn a root into a fraction as an exponent. So here we'll have 96x to the power 1 over 2. That is the same thing as square root of 96 to the power x. So we already know what we are now going to do with the numerator and with the right-hand side. So let us now go and do that. So we discussed that we're going to break up the left-hand side into 3 to the power y times 3 to the power 1. And that is all over 32, which is equal to 96x to the power 1 over 2. From here, if you notice, we have 32 and we have 96. We need to try and build a relationship between those two. We need to try and break them up, because what else can we do? So if you notice, we already have 3, right? And we know that when we are dealing with exponents, we like to keep the bases the same. So 32 or 96 needs to be broken up into a base of 3 if possible. We know that we can't break up 32 into a base of 3, right? We know that 32 can be broken up into 2 to the power 5. Now, because we now have a base of 3 and 2, that means we need to break up 96 into a base of 3 and 2, if possible, or into a base of 2 only or 3 only, or 2 and 3, it depends. So we need to try and identify what we can break up 96 into. Before we move on to breaking up 96, does anyone have any questions on how we broke up the numerator and how we got 2 to the power 5, or how we got this exponent of 1 over 2? Is there anyone that has any questions? Okay, then let us proceed. So from here, we need to break up 96, right? So we know that 96 can be broken up into 3 times 2 to the power 5, because we know that 32 times 3 is 96, and 32 is 2 to the power 5, right? So we are now basically going to break up 96 into 2 to the power 5 times 3. That's all we are now going to do. So let me just erase this so we can get started. So from here, we break up 32 into 2 to the power 5. We can break up 96 into 2 to the power 5 times 3, and that is to the power a half x. All I did was I multiplied x and a half. Remember the rule that we discussed earlier: when you raise a power to another power, when you raise an exponent to another exponent, all you need to do is multiply the exponents. Now, from here, we are going to distribute that exponent into the bracket. We're using the exact same rule. When you raise a power to another power, you multiply the exponents. So we are going to distribute this a half x into the bracket. Keep in mind that the exponent of 3 is 1, okay? So when we multiply, we are going to multiply 5 times a half x, and we are going to multiply 1 times a half x. So let us start. I'm actually also going to move this 2 to the power 5 to the top, okay? Take note that when you move something from the bottom to the top, the sign of the exponent changes. So it's going to become a to the power negative m, okay? If you move from top to bottom or bottom to top, sign changes. Positive becomes negative, negative becomes positive. The reason I'm doing this is because I don't want to have a denominator anymore. So, yeah. So 3 to the power y times 3 to the power 1 times 2 to the power negative 5 is equal to 2 to the power 5 over 2x times 3 to the power 1 over 2x. All we did was multiply the exponent outside of the bracket into the bracket. That is it. From here, something that you should notice is that we have bases of 3 and 2. Now remember what we did previously. When the bases were the same, we dropped them and we only dealt with the exponents. So that is what we are now going to do. I'm going to make all of the bases of 3 equal to one another and all of the bases of 2 equal to one another. So if you want to do that, right, take note that we could have kept this the same. This 3 to the power y, we could have kept it as 3 to the power y plus 1. Technically, we didn't really need to change that one, okay? But yeah. So all the ones that are 3, let's move them to the left. So we have 3 to the power y plus 1. I'm going to move it back to y plus 1. And that is equal to 3 to the power a half x. If you want to, you can also leave it as 3 to the power y times 3 to the power 1. You just need to remember that when you move it from an exponent to a to the bottom, you need to put the plus sign, okay? So however you choose to do certain things, you just need to take note that rules still apply, okay? So if you wanted to do this, 3 to the power y times 3 to the power 1 equals to 3 to the power a half x. When you brought the exponents to the bottom, you should have remembered that it still needs to be plus, and that is equal to a half x, okay? So you could have also done that.
So can I ask, I don't know if I'm the only one, but is it the only thing on your screen, is it like your thingy?
Yeah, to me
Yeah,
too.
because I can only see like based on what I see on the screen, the only thing that like you have ne is 3y. It didn't even complete like a plus sign. So I don't know if it's my screen or does it apply to everyone?
If I draw
Yeah.
a green circle, can you guys see that green circle, or do you not see it?
We can see it.
You can see it.
Does everyone see the green circle?
Yes.
Yes, sir.
Yes, I can.
Okay, the student that
Yes,
said
sir.
you couldn't see earlier, though, you said it stopped by a Y. Do you see the green circle now?
Yes, I do, sir.
Yes,
Now
we
it's
can see
visible
it.
after you do the green circle,
I
like
think it's
everyone else was
updated now. Okay, so let me just repeat what I said earlier. What I said earlier was here, remember we originally broke up 3 to the power y plus 1 into 3 to the power y times 3 to the power 1. As we moved through the question, I realized that we didn't really need to break it up. A lot of the time you'll see that you do need to break it up, and then other times you'll see that you don't. So it kind of depends on what's going on. So as we moved through the question, I noticed we didn't really need to break it up. So that's why I brought it back to the original form. If I draw the square in green, can you guys still see the square? Does no one see the square?
yes,
You see? Okay.
we can.
As I'm
Yes, we
writing,
can.
I'll always verbally state what I'm writing down. So if I say something and you don't see it being written down, just let me know. Sometimes I need to restart the sharing feature. Sometimes it's Signal. It depends, but yeah, just let me know, please. So what I was saying earlier was if we kept it as the original form or as the broken up form, as 3 to the power y times 3 to the power 1 equals 3 to the power 1 over 2x. Take note that I'm writing some stuff in green. If you do not see it, let me know. So if we kept it in that form, when you drop the bases, you need to remember that it's still the exponent law. So you needed to remember that you were supposed to add the exponents, okay? So to avoid forgetting, I would recommend leave it in that form, okay? Because I just now noticed that you didn't really need to break it up, okay? So yeah, I'm now erasing the green writing. So if you don't see it, please let me know. Okay, the green writing's gone. We're going back to blue. So from here, we're going to drop the bases. So we'll have y plus 1 equals to a half x. From here, we now need to solve for x or y. But keep in mind, we still have two variables. So I'm going to stop there for now. I'm going to leave that equation on the left because I can't really solve for x, nor can I solve for y, because I have two variables. But if you look at the twos, the bases of twos, you'll notice that there's only one variable, x. So I'm going to stop there for now. I'm going to go to the other equation, solve for x, then come back to the left-hand side. So here, or now we're going to equate the twos, the bases of twos. So 2 to the power negative 5 is equal to 2 to the power 5 over 2x. From here, because the bases are the same, we are now going to drop the bases and we only have the exponents. From here, all you now need to do is solve for x. So if you divide both sides by the coefficient of x, take note that the coefficient refers to the number that is in front of x. If you have 3x, your coefficient is 3. If you have negative x, your coefficient is negative 1. If you have 10x, your coefficient is 10. The coefficient refers to the number that is in front of the variable. So in this particular case, our coefficient is 5/2. So what we are now going to do is we're going to divide both sides by the coefficient. So -5 divided by 5/2 gives me -2. That means that x is equal to -2. Now that we have the value of x, we are going to take that value of x and substitute it into the equation on the left-hand side. And that will allow us to solve for y. So before I move back to the left-hand side, I'm zooming out now so that you should be able to see the entire question. Does anyone have any questions? Is anyone confused by any of the steps? Is there something that we need to go back and re-explain? If you have an issue, please let me know so we can address it. Okay, so let us continue. Now we're going to take that x, substitute it into the equation on the left. So we know that x is -2. So where you see x, you just put -2. So y plus 1 is equal to 1/2 into -2. From here, we can put the left-hand side into our calculator and you should get -1. So we then have y equals -1 minus 1. +1 to the right, the sign changes, it becomes -1. From here, all we need to do is put that into our calculator and you get -2. So we now know that x is equal to -2 and y is also equal to -2. And that's it, we are done. All you needed to do was play around with your exponent laws and you should have been okay. So yeah, this is from, I think, a grade 12 paper, if I'm not mistaken. Let us move on. So next we have example 14. What's nice about example 14 is it's squared. All our previous examples were exponents or linear examples. Now we've got a squared variable. So how do we deal with that? Whenever you have a squared variable, look at the other equation. Look at the equation that's linear, the equation that's not squared. That equation, you need to solve for either x or y. I would prefer to solve for x in this equation because the coefficient of x is 1, whereas the coefficient of y is 2. That would mean if I wanted to solve for y, I would have to divide everything by 2. Then I'll end up with 3/2 and x/2. I don't want to deal with fractions. It makes life complicated. So I would rather solve for x. I'm going to make x the subject of my formula. I'm going to take that equation of x and then substitute it into the second equation. So that is what we are now going to do. So let's start. If we want to solve for x or make x the subject of our equation, we can take 3 to the other side, making it -3. So we then have x equals 2y minus 3. Now that is equation 1. We are going to take that equation 1 and substitute it into equation 2. So equation 2 is 2xy plus 7 equals x squared plus 4y squared. A quick side note, always double check the question. A lot of the times you copy the question from your exam paper and you're writing it down, you're in a rush, you could mess up one of the terms or something in the equation. Always double check that what you've written is correct. It's happened to me many a time whereby I copy the wrong question because I'm in a rush. So just make sure that you copy the correct question. So from here, we are going to take equation 1 and we are going to substitute it into equation 2. So where we see x, we are going to substitute 2y minus 3. So here we have 2 into, there's an x, so we substitute 2y minus 3. After the x comes y, plus 7 equals, there's another x, so you substitute 2y minus 3. There's a squared sign after that, plus 4y squared. So we write it as is, just wherever you see an x, you replace it with 2y minus 3. Everything else stays the same. So let us continue. From here, we need to distribute the 2 into the bracket. So that is going to give us 4y minus 6. And we have that y at the back. That is one way you can do it. If you don't like having something behind your brackets, what you can do is you can move the y to the front. So you make it 2y times something. Remember, 2 times 3 is the same as 3 times 2. When you are multiplying, the order doesn't matter. Whether you put A first, B first, or C first, when you multiply, it doesn't matter. So we are going to write this as 2y into 2y minus 3. All I've done is I've moved that y to the front of the bracket. It was originally at the back of the bracket. And we have plus 7 equals. Now, that 2y minus 3 all squared, you can use your FOIL method there. Because it's squared, it means you repeat it twice. So 2y minus 3, 2y minus 3, plus 4y squared. We're going to use our FOIL method and solve for that double bracket. So here, before we even get to the right-hand side, on the left, we are going to distribute this 2y into the bracket. We are going to say 2y times 2y and 2y times negative 3. That is going to leave us with 4y squared minus 6y plus 7, and that is equal to, now we're going to distribute this 2y into the second bracket. So 2y times 2y, that gives us 4y squared. 2y times negative 3, that gives us negative 6y. Negative 3 distributed into the second bracket, that's going to give us negative 6y plus 9. Now, what you should notice from here is that these two middle terms are like terms. Now, I'm going to present, let's say 3 options. I want you to tell me which is the correct option. Is negative 6y minus 6y equal to positive 12y? Is it equal to 0, or is it equal to negative 12y? Which is it? Option 1, 2, or 3?
Option 3.
Option 3.
Option
That-
3.
That is correct. So it's option 3. Now, let us continue to simplify. So here,
Sorry, sir.
I'm just going
So,
to, yes.
so may you please explain how it's option 3? Because I thought that 6 minus 6y, they cancel out.
Okay, think about it like this. So you borrowed 6 rand from me, right? On Monday, you borrowed 6 rand. Then Tuesday, you came back and you borrowed another 6 rand. How much do you owe me now?
I owe you 12 Rand.
So think of negatives as owing someone money. So -6, -6. Or think about it like this. There's two rules, right? When you are adding integers. So rule number one is if it's got the same sign. So think of it as same sign and different signs. That's how I remember the rules. You can use whatever name you want to remember. So same sign, and rule number two is different sign. So if it has the same sign, the rule is to repeat the sign and then add the numbers. An example of this is -6 and -6. It has the same sign, right? So you repeat the sign and then you add 6 plus 6, that gives you 12. Another example of this, let's say both are positive. So let's say you have +5 and 6. Both are positive, so you repeat the sign, positive sign, add the 2, you get 11. So when you are dealing with the same signs, repeat the sign, add. When you are dealing with different signs, take the sign of the bigger number, and then subtract. So let's say we have -11 plus 2. The bigger number is 11, so we take the negative sign. Subtract 11 minus 2, you get 9. That's addition of integers. This is one method. But because you have the option of using a calculator, let me show you something else that you can do. So because you have access to a calculator, you are dealing with -6y minus 6y. On your calculator, take all the numerical values of the like terms, put them into your calculator, and then just bring down the variable. So on your calculator, put -6 minus 6, and then bring down the variable. On your calculator, -6 minus 6 will give you -12, and bring down the variable. So this only applies to like terms. Don't go and put down all the numerical values of everything. That's going to be wrong. Make sure that you are only putting down or inputting the numerical values of the like terms into your calculator. Then just bring down the variable. For example, let's look at one more example. If you have 3a plus 2b minus, let's say, minus 5a plus 10b, for example. On your calculator, you should notice that 3a and -5a are like terms. So on your calculator, put 3 minus 5 and then bring down the a. On your calculator, put the b-like terms. So 2 plus 10, bring down b. You'll get -2a plus 12b. Okay, so just put the numerical values of the like terms into your calculator, bring down the variable, that's it. Then to bring your attention back to what you mentioned earlier about the 0, take note that when you have a positive and negative of the same thing, that is when you have 0. -6 plus 6, that's 0. This can be rearranged into something that you're more used to, 6 minus 6. All we did was we swapped the positive and negative terms. We moved +6 to the front and -6 to the back. So only a positive and a negative of the same thing results in a 0. So yeah.
So can I ask you a quick question
Yeah.
regarding what you just said right now? I know that it's off the topic, but then I just really wanted clarity on the thing. So whenever you deal with exponents, and then you have maybe, okay, like -6 and +6, right? When you have to add them or subtract them together, either way, -6, +6, and then they give you a 0. So does that 0 automatically, do you like cancel it completely, or does it become like a 1? Does the whole thing become a 1?
Okay, no, it never becomes a 1. So remember, 0 is nothing. Nothing can't become 1. It's kind of like if you don't have a car, you can't have one car. If you have 0 rands, you can't have 1 rand. So nothing can ever become 1. So the law that you are thinking about is something to the power 0. That is equal to
Yes,
1.
sir.
Anything to
Yes.
the power 0 is 1. It doesn't matter what it is. It can be 1,000,000, 100, 1,000, -1, a half, x, y, z. Anything to the power 0 is 1. But be careful with that. It can be represented differently in a question. For example, 3a to the power 0 and 3a all to the power 0. Even though they may look similar, they are different. The first answer is 3, the second answer is 1. Now, the difference in this is that, do you see here in the first one, only a is to the power 0. So you repeat the 3, change a to the power 0 into 1. 3 times 1 is 3. Everything to the power of 0 is 1, because they're now telling you that everything within that bracket is to the power 0. If you were to distribute the 0 into each term, you'll have 3. Remember, 3 is to the power 1 times 0. A to the power 1 times 0. 1 times 0 is 0. So that becomes 3 to the power 0, a to the power 0. 1 times 1, that's 1. That's the long version. The short version is to remember that because everything is to the power 0, the whole thing becomes 1. So yeah, please don't confuse that. It's only if the exponent is 0, then it is 1. If it's equal to 0, then it's equal to 0. 0 is nothing. If it's equal to 0, it is nothing. It's not 1. Okay. Yeah.
Okay, thank you so much.
Okay, so back to what we were originally doing. Let's just do a quick recap. So what we did earlier, what we did when we started, was we identified that we can make x the subject of the first equation. Once we made x the subject of the first equation, we then took that equation of x and substituted it into the second equation. So that 2y minus 3, that was substituted into the second equation, and that became what you see here. From there, all we were basically doing was using our simplifying techniques that we learned in grade 10 to distribute into the bracket or to use your FOIL method. All of that was discussed in grade 10. Please go back to your grade 10 textbook and revise those concepts if you have forgotten. Now, from here, we mentioned that -6y, that becomes -12y. And then you have +9, and then +4y squared. So basically, this 2 brackets over here became these 3 terms over here. Okay. Now, from there, we need to simplify. We need to solve for y. So what I'm going to do, because I have y squared, I'm going to move, actually, I'm not going to end up with y squared, am I? Actually, I will, yeah. Because I was thinking this 4y and 4y would have canceled each other out. But then I noticed there's another 4y. So we are most likely going to end up with a quadratic equation. Keep in mind that when you are dealing with a quadratic equation, it means you're going to end up with 2 values of x and y, okay? So here we're going to move everything to the left. So what's already on the left, the signs stay as is. Do not change the signs. What you move from the right to the left, all of these, their signs are going to change. So 4y squared becomes -4y squared. -12y becomes +12y. +9 becomes -9. +4y squared becomes -4y squared. Now we need to add up like terms. So let's see. Our like terms, we have y squared, and y squared. These are our first set of like terms. So 4 minus 4 minus 4, That gives me -4, and you bring down the variable. Let's have a look at the next set of like terms. We have -6y, so anything that has y, here we have positive y. So -6y plus 12y, 12 minus 6 is 6, bring down the variable. So plus 6y. And lastly, we have these constants. Keep in mind, constants are values with no variable. So those constants, 7 minus 9, that is -2, and that's equal to 0. From here, now that we've added up all the like terms, you should notice that there's a common factor being 2. In addition to that, you can see that the coefficient of your squared variable is negative. So you can even factor out a negative sign. Or you can divide everything by -2. I'm going to divide everything by -2. That'll leave me with 2y squared minus 3y plus 1 equals 0. So all we did was we divided both sides by -2. An alternative approach is to factor out -2, then divide both sides by -2. So that is one of the approaches that you can take. Now, from here, we need to factorize this trinomial. We know that the factors of 2y squared are 2y and y. We know that the factors of +1 are -1 and -1, or +1 and +1. But if you notice, the middle term is negative. So I'm going to go with the negative factors. That's -1 and -1. From here, we can cross multiply and then add them to see if it gives us the middle term. So that'll become -y. That'll become -2y. Add them up, -y, -2y, that gives us -3y, which is the middle term, as you can see, which means our brackets are correct, or our factors are correct. So our brackets would basically look like this. So 2y minus 1 and y minus 1 is equal to 0. From here, we know that y is equal to 1/2, or y is equal to 1. Now, that is only the value of y. In order for us to find the value of x, we take this value of y, substitute it into one of the equations, and solve for x. So I'm going to substitute it into this equation 1. That's 2y minus 3. So x is therefore equal to 2y minus 3. We can substitute a half. And when you put that into your calculator, you should get 1 minus 3, which is -2. So when y is -1, x is -2. Now we need to find out what is the value of x when y is +1. So same equation, x equals 2y minus 3. Substitute the value of y, which is 1. And 2 minus 3 is -1. That means that when y is a half, x is -2, and when when y is 1, x is -1. So that's basically it. Yeah, so that is example 14. If you want to double check your answer, you can substitute into the original equation. If the left-hand side is equal to the right-hand side, that means what you have done is correct. Okay, so we will end here. Yes, you were saying?
So before we end the call, so even like, that step where we took out the common vector between the quadratic that we had and it was a 2. So even if it was a -2, it was still going to give us the same result, right? So it doesn't really matter if it was a positive or negative.
Okay, so where I took out a common factor, you could have just left it as is. So here, just give me a second to get rid of this. You could have just said that a is equal to -4, B is equal to 6 and C is equal to -2, and use your quadratic formula, you would have ended up with the exact same answer. It doesn't matter. Another option is you could have divided both sides by -1, and you would have ended up with 4y plus 6y plus 2 equals 0. You would have ended up with the exact same answer we got. Another option is you could have only taken out the 2. So if you factor out the 2, you'll then be left with -2y squared minus 3y, plus 3y minus 1 equals 0. Divide both sides by 2. That cancels that. You left with -2y squared plus 3y minus 1 equals 0. The reason I don't like to have a negative as my coefficient of my squared variable is because it makes things tricky when you're doing your bracket factorization. It's easier if the coefficient of your squared variable is positive, and it's easier if it's simplified as far as possible, meaning that you've taken out a common factor. Whenever you are simplifying, the first thing that you need to look for is a common factor. As long as you take out a common factor, the rest is slightly easier for you to do. So yeah, before we end, does anyone else have any questions?
So I wanted to ask, for the final answer, is it a must for us to also substitute the positive 1 back into the first sum we got?
The positive 1, you mean the values of y?
Yes, sir.
You could have substituted the value of y into this equation, or this equation. It doesn't matter. This one here is just the easiest because you already solved for x. You just plug y in and you'll get an answer for x. Does it make sense?
Yes, sir. Thank you.
So yeah, that's basically it. So we'll end here for today. Then I will see you guys the next time. This PDF will get uploaded to that. Yes.
Before we end, for this question, how marks are we looking at? How many marks?
For question 14, example 14, you could say like 4 or 5 marks. Simultaneous
Okay.
equations is usually around 5 marks.
Thank you, sir.
Okay. So this PDF will get uploaded to that OneDrive folder under the folder class. I think it's called PDFs or group class, something like that. But yeah, I'll send a message in the group once it's been uploaded. But once it's been uploaded, you can view it there using the original email. I'm not going to send out a new email. Please click on the email that was sent. Yeah, so click on that email and then you'll be able to see this PDF. There's a lot of questions here. I would recommend, because you're busy with the exponents, have a look at example 20. It's quite interesting. I think, yeah, have a look at example 20. It's quite interesting. You can attempt these questions on your own as well, okay? So we'll end here for today. Thank you guys for attending, and I'll see you the next time, okay? Bye, everyone.
Bye, sir.
Bye, sir.
Bye.